All right, y'all. First of all, like and subscribe. Boom. Knock that out. Help a brother out. Okay? Anyways, we are going to do verifying trigs again today. All right? So I'm going to do 4 examples. Okay? It's good to, expose yourself to a lot of this stuff. So just keep that in mind. That's what we'll be doing. Okay? I have posted all of these. All right, with the keys, the evens is the homework, okay, or the worksheet, and then the rest of it, like I said, I'm gonna do 4 problems. It's gonna take a decent amount of time, and then the rest of the solutions for the odds will be on Google Classroom. Okay, so you can take a look at those. So just keep that in mind. Again, it's good to see a lot of examples of these, but I've tried to pick 4 that I thought had creative steps, or maybe steps we haven't seen, maybe some we have seen, but just, I try to pick some of the more creative ones, and then I picked 2 really hard ones. Number 9 and number 11 are pretty lengthy verifying trig problems, so I picked those as well. So the rest, hopefully, you can get a pretty decent grasp of it, but I think number 9 and number 11 are 2 of the more difficult ones. Okay? So we're going to do 5, 7, 9, and 11. So here we go. Let's go ahead and start with number 5. All right, number 5 is right here. We got 1 minus sine of x over cosine of x is equal to cosine of x over 1 plus sine of x. Now, the first way I would approach this, or probably the best way I think approach this particular problem, is to do what I like calling introducing the denominator here. Okay, so we're starting here, right? We've got 1 minus sine of x over cosine x, and we need at some point to have this denominator. Okay, so when we see something like that, when we've got this is my denominator here, just cosine, okay, and we're trying to reach this point here. Well, then what we might as well do is we might as well just introduce that denominator. So that's what I like calling introducing the denominator. And that's what we're going to do here. We're just going to multiply the top and the bottom by 1 plus sine of x. Okay, so that's a nice little trick, because now we have 1 plus sine of x on the bottom. Now really the only goal is to just cancel cosine, right? Because over here we just want 1 plus sine of x. Notice there's no cosine, right, on the bottom, on this side. Okay, so that's, multiply by a fancy version of 1. That's what I like to call it, fancy 1, right? This over this, that's the same thing. So we're not changing this value. Okay, so multiply by a fancy version of 1, or introduce the denominator. And then we just do that, and then from there we just kind of see what happens. Okay, so that's a really nice step if you need a denominator that you don't already have in your problem, okay, or in your starting point. Okay, so let's go ahead and see what happens from here. Let's just multiply everything out. Let's just go ahead and write it first. So 1 minus sine of x, right, and then 1 plus sine of x. And then on the bottom we've got cosine x over 1 plus sine of x. All right, so we don't notice one thing that people are tempted to do a lot of times is they'll want to say, oh, look, I have this here and this here, cancel it. Well, guys, if we cancel it, we're literally right back up here. Okay, so don't get stuck in that loop there. All right, so I'd say this is just a rewrite, right? We're just showing the multiplication. All right, so that's a rewrite. From here, let's go ahead and FOIL out this and this, okay? And let's just see what we end up with. So we've got, and now, again, the way I approach it, right? How do I know to do that, okay? Truth is, I don't really know to do that, okay? I like, my goal here, okay, my goal is to cancel that cosine, because basically once I get rid of that cosine, now I should end up with something that is just this up here. So I don't know to do that, but we're just going to try it out. We're just going to multiply the top and see what happens. So we do it, and we see that it's a difference of squares problem. So I end up with 1 minus sine squared of x all over cosine. Now, you may want to distribute here, right? I'm actually not going to. And again, this time is a little bit of cheating, if you want to call it that. I have a little bit of foresight on this problem, so I know that it's actually better for us to keep cosine here. Because again, if we were to multiply it out, I guess that's not quite cheating. If we were to multiply it out, we're going to end up with something that's not 1 plus sine of x. We want to try to maintain that 1 plus sine of x as best we can. Okay, so we don't want to get rid of it, right? If we distribute it, it's not going to look like 1 plus sine of x. We want it to look like 1 plus sine of x. Okay, so moving on forward here, we've got, here we just got this 1 plus sine of x, right? So we're good so far. Okay, and again, this is our classic opportunity that we want to see. We have one of those Pythagorean, sine squares, right? I see sine squared, and I've got to see that potentially I see a sine squared and I see a 1, and I've got to think potentially I'm going to use Pythagorean identities. Okay, so over here, right, 1 minus sine squared, okay, 1 minus sine squared ends up being cosine squared. Okay, so that's the first set of my Pythagorean identities, right? It's like a little family of Pythagorean identities. Okay, so this was the step that we did here. I guess we foiled. All right, but on my next step, I'm going to go ahead and use the Pythagorean identity. And I'm going to convert that to cosine squared. Now, if you're remembering, you should see that that's actually a really important and key step, right? Because what was our goal? We wanted to get rid of cosine on the bottom, right? We wanted to get rid of that cosine on the bottom. Well, look, I have a cosine on the bottom here. Now I have something to cancel it with, okay? And so from here, we just cancel, and you should be able to see, right, this cosine goes away, one of these goes away, and it's still left on the top. So that's exactly what we're trying to work towards, and we cancel it, and we are done. We are done with that one. So cosine of x on the top, and then over 1 plus sine of x. And that's our first verifying trig identity for the day. All right, so that's a good one. That is this is the goal, right? I introduced the hard ones because it's challenging you, right? But this is like a great example of one that really everyone should be able to do. I'm not saying that if you can't do it, you need to step it up or anything. I'm just saying this is like the you're getting pre-cal if you can do this. Okay, this is like the standard, right? A lot of the other ones, the longer ones, are like stretch problems or problems that are trying to challenge you. Okay, that is a great example of a relatively basic one, right? We're using a couple different steps. We're multiplying, we're foiling, Pythagorean identity, cancel, done, right? Okay, that's number 5. That's a solid problem. Okay, number 7. All right, number 7, also a great problem. Good kind of standard problem again. So let's go ahead and do it. Number 7. Secant to the 4th minus tangent to the 4th equals 2 times tangent squared of x plus 1. Okay? All right, so here we go, number 7. All right, the first thing I noticed about this problem, okay, let's go ahead and write my first step. All right, secant to the 4th of x minus tangent of 4th, to the 4th power of x. All right, and the first thing I noticed about this problem is in my answer, right, in what we're trying to show, I don't have any secant, right? I don't have any of that secant to the 4th, right? I just have tangent, okay? I don't even have any other trig ratios. It's just tangent on that left side. So the first thing I want to do is I want to keep my eye on that, right? Because the goal here is to get rid of everything that's not tangent, right? So if I can just get everything into terms of tangent squared, then it should naturally play itself out. Okay, so if I work with the goal of getting rid of everything that's not tangent, in other words, getting rid of this secant, then it's basically going to be like combining like terms. Okay, that's typically how these work out. Okay, so let's go ahead and think, right, how we can get rid of secant. Well, we see secant to the 4th power. We're probably more comfortable with working with secant squared, right? And if we noticed, secant squared, right, no coincidence here, that it's in the family, right, with tangent in the Pythagorean identity, right? So if I can just convert that to secant squared, all right, then I can replace it with some tangents, okay? So that's our goal, all right? But let's get it into secant squared first, okay? So secant squared, we're going to change that to secant squared, okay? All right, so I'm going to rewrite this as, okay, rewrite, or you could say this is like factoring maybe, or you could say it's, you know, undoing the square. I don't know, something like that. Square root, maybe, something like that. Right? So, anyways, secant squared, but all of that squared, right? Because secant squared times secant squared is going to get you secant to the fourth. Okay, so I've got secant squared squared, all right, and then minus tangent to the fourth of x. We're going to keep that for now, right? We want to keep some of the tangents, right? We don't want to just completely get rid of everything, okay? For now, we're going to focus on this. All right, so now we have secant squared. Let's go ahead and use a Pythagorean identity because I know what secant squared is, right? Secant squared is 1 plus tangent squared, right? That's that first one of the family, right? 1 plus tangent squared is equal to secant squared. So let's go ahead and write in the parentheses 1 plus tangent squared. But don't forget, it's all that. Like, that's just the secant squared. We've also got to square that. Okay, and then minus tangent to the fourth. Okay? So that doesn't do us anything like by itself, but if we multiply it out, maybe it will. So let's go ahead and multiply, right? We're going to take care of the squaring. So we're going to FOIL, okay? Or you could perfect square, right? Perfect square multiplication, right? So to save us some time, I'm going to go ahead and do that. We've got 1, ends up being 1 plus 2 tangent squared x, and then plus tangent to the fourth of x. That's that entire thing. And then we've got to remember this, okay? This is foiling, right? That's how we got that right there. So you should see something kind of nice here. We end up, you know, adding this, but then subtracting these two are the same, okay? So we can just get rid of that, combine like terms, combine our like terms, and we end up with, if we were to reorder it, right, just we have that 2 tangent squared, that's this part, and then plus the 1. So I'm going to go ahead and write it in the same order. And we are done there. Okay? So, another really, really good one, right? Where you see over here, we've got a secant. There's no secant in our answer. Let's get rid of that secant. Well, how can we get rid of it? We know secant and tangent play together in the Pythagorean identity, so we can use that Pythagorean identity to get rid of it and change it to tangent. So that's the approach that we take there. All right, we're buckle our seatbelts on, and we are going to annihilate number 9 here. Number 9 and number 11 are tough, okay? Understand that it took me a while to do these, right? So it's just important to keep that in mind. These are definitely ones you might get stuck in a loop, a little bit confused and all that. But they're also good problems to learn because I introduced some little bit of creative approaches here. Okay, so let's go ahead and start. And again, I'm going to try to approach this as if I had not seen it, right? I know I did one solution. I did these yesterday, okay? I did these yesterday, and maybe my brain takes me in a different spot today as I approach this. Okay, so over here, all right, on number 9, okay, what we're working with, we'll just get a quick refresher, okay, yeah, all right, so what we're working with on this one, okay, is we also have another one where we're going to try to introduce that new denominator. So if you notice, I have tangent squared here, okay, I've got tangent squared. I just want secant minus 1. Right, I just want that. So I'm going to try to introduce that. And then, actually, I'm going to try something different. We're going to go off the rails here. That's just where my brain is right now. We're just going to go off the rails and see what happens. Yeah, we're going to try something new. So, understand we're in uncharted territory here. I did this another way on the key, so if that works, that works. Okay, let's try something different. All right. Yeah, this is going to be interesting, but we'll try it out. Okay, let's get rid of this tangent squared. That's how I want to start on this. Okay, if it doesn't work out, it doesn't work out, and we'll just see what happens. Okay, but that is how you have to approach these, right? That's just you try something, right? You're in uncharted waters, right? Like that's how you guys are doing these problems. So you have to try something new every once in a while. Try it, see where it goes, and if it gets stuck, it gets stuck. That's okay, and that's just the nature of these problems. All right. So we're gonna write it first, and let's see what happens here. Let's get rid of that tangent. Now the reason I say to get rid of the tangent, remember tangent and secant have that relationship, right? So if I'm kind of aiming towards secant, I'm going to try to replace that tangent to secant squared, right? It's Pythagorean identity here. And then we're going to try to factor and see what we kind of end up with, okay? So we've got cosine plus 1, okay? We've got up here, we've got tangent squared, right? So we're going to replace it with the Pythagorean identity. Just tangent squared is secant squared of theta minus 1. Okay? So let's do that. Secant squared of theta minus 1. All right, and again, I'm trying something new here. I posted the other solution the way I did it before over there. And it may have even, I'm not quite remembering, it may have even used this step a little bit. I'm not sure. Okay, I'm not sure. All right, so anyways, we've got secant squared of theta minus 1. Okay, let's go ahead and factor. Now, here's the advantage to factoring. Here's why I know to factor, right? Because if I factor, I can actually get this secant theta minus 1. I can actually kind of introduce that, right? So let's rewrite it. Let's factor here. Cosine of theta plus 1. And then over here, right, I can do secant theta minus 1. And then times secant theta plus 1, right? That is the perfect square, right? That's the perfect square on that. So yeah. All right, so we're here, okay? Let's see. So we are theoretically changing. Let's see. Theoretically, we need to cancel this secant theta plus 1, okay? That's kind of our goal. Our goal now is to cancel that secant theta plus 1. So we can't just put it on top to cancel it, right? That would change the value. So, but at some point, we're going to need a secant theta plus 1 on top in some manner, okay? So let's try this. Okay, let's try this. I don't know if this is going to work or not. I see this 1. Let's try to use our Pythagorean identity. All right. Let's do. I think this is going to work out. I think I'm starting to see it. So let's get a secant in here on top and see what happens. So let's replace this 1 with secant squared of theta minus tangent squared of theta, and let's see what happens. Okay. Cosine of theta plus 1. All right, secant of theta minus 1, secant theta plus 1. Oh, and then kind of forgot what we were doing. Okay, replacing this 1 here with secant squared of theta minus tangent squared of theta. So secant squared of theta minus tangent squared of theta. Okay. All right, so let's see where that takes us. Okay. Thinking. Okay. And then let's do let's get cosine. I'm going to pause it to reconvene with you guys and see if I can come up with something. I'll kind of explain my thinking in just a sec, but I don't want to waste y'all's time with the video. Okay, I'm going to take that step back. I think I'm going to approach this differently. I'm going to change things to secant. That's what I'm going to do. Okay, I'm going to change that cosine to secant, and we're going to see what happens there. Okay, I think this is a better approach. All right, so we've got. Let's get reorganized here. Okay, we've got cosine theta plus 1. Let's go ahead and change this. Let's do this. We're going to change that cosine. I know it's going to be a little bit weird and a little bit backwards, but we're going to change it to 1 over secant. Okay, and then we're going to do plus secant over secant. Let's see what happens when we do that. Yeah, this is better. I think I'm starting to see it. Okay, you should see it a little bit too. Let's try this. So how I know that, I don't know. I'm trying to get things into secant, right? That's what I'm trying to cancel. No, I guess this is how I know it. So I'm trying to get this to cancel, right? I want secant theta plus 1 on the top somehow. So what I notice is I've got cosine of theta plus 1 on the top. So I want some secants. Well, let's introduce some secants, right? We know that cosine of theta is 1 over secant. And then in order to actually add these, we've got to change this to secant of theta over secant of theta. So that 1 here is this 1 right here. All right, so what we did is we did reciprocal identities, and we did common denominator as well. Okay, now, this is it. Yep, this is it. I see it now. Okay, so we've got, we can combine these up top, so let's go ahead and combine them. We've got 1 plus secant of theta over secant of theta. That's basically it, right? Like, it actually, I'm so glad I tried something different. Yeah, the solution that the route that I took wasn't the best route. And that's what's so great about these problems. I just love it. All right, so anyways, so now what you should notice is we have a 1 plus secant on the top of this fraction, the entire big fraction, and we've got a secant of theta plus 1 on the bottom. So we can now cancel. What we did here is we just combined, okay? And we can cancel in our next step. So canceling the 1 plus secant theta and the 1 plus secant theta, right? They're factors. We're dividing, we're multiplying, so we can cancel this and cancel this, all right? But be careful up top, because now I'm left with 1 over secant of theta on top, all over secant of theta minus 1. Well, what is 1 over secant theta? That is cosine, and that is our goal, and we are done with this particular problem. Okay, so it's the cosine of theta over secant of theta minus 1. And the uncharted waters we are out of. So that is that's good stuff right there. That is some good stuff. So we've got we're done here. What did we do? We just did the reciprocal identities. Okay, so we made it out. Whew, we made it out alive. That's okay. That is. I'm glad I did that, guys, because hopefully you see the natural process of figuring these out. This is silly to copy a solution down with these, right? Because the whole point is to figure them out on your own and to take your own approach. And if you can work your way out, it's pretty satisfying. I'm not gonna lie, like it's like one of those like satisfying videos that you see, like, oh, that's such a satisfying video. That's what this should be. That's what this should be. That's what this is for me. I'm gonna be completely honest. So, all right, that's number 9. Maybe I'll try to approach number 11 the same way and see if I can come up with a different way. I don't know. See how I feel in just a second. All right, number 11. Number 11. Number 11 is, whew, gosh, this is a big one. All right, secant of theta minus tangent of theta squared plus 1 all over secant of theta cosecant of theta minus tangent of theta cosecant of theta. We get all of that is 2 tangent theta. Okay. Let's see how bold I'm feeling. I'm feeling bold again. You know what? We're going to do it. We're going to do this a different way. Let's see the approach that I took. Maybe not. Maybe not. This is a tough one. I'll come back when I'm ready and I've decided. All right. Yeah, I think this is a little bit dangerous to approach it in a different way. I don't want to approach this in another way. So I'm gonna stick with what I did the first time. So I actually think this is a great problem to work backwards. And you'll see on my notes that I actually realized that I think halfway through. So I think let's try this one backwards. Now the reason why I say that, all right, is because the approach I'm going to take here is I'm going to start with 2 tangent of theta. Okay, so I'm going to go ahead and write that, 2 tangent of theta. And then what I'm going to do is I'm going to introduce this scary looking denominator. Okay, there's a ton in that denominator. And so I think what scares me about approaching this a different way is there's so much going on here. There's three different trig ratios, right? We got secant, cosecant, and tangent. That's just terrifying to me, right? If we can't, like, you want to piece them together, like, and you want to be able to cancel things, like, we're going to have to get rid of that at some point, right? So you just got to be, I don't know, it just makes me nervous. It just makes me nervous on that one. So we're not going to approach it that way, okay? We're going to approach it as, we're going to do 2 tangent of theta, and then we're just going to introduce the denominator immediately, okay? And then what we try to do, I'll show you, okay? We're going to introduce the denominator. And the reason why this is a safer route is because now, I'll show you. The reason why this is safer, right? I'm introducing the denominator, and I'm going to see what happens, right? And so the reason why this is actually a safer route is because we're just multiplying this on the top and the bottom. And now the bottom is taken care of. Like, I've got the bottom good, right? Like, we multiply by, I'll write the steps. Multiply, common denominator, and the goal, right? That's our goal. We're working from here to here. That's our goal. So the reason why that's nice is because now I already have that stuff on the bottom. We're good. Like, we got this part taken care of. Now all I need to do is show that the top, right, that this times this is that stuff up there. So it really becomes, it kind of simplifies the process in a way where, like, bottom's good, okay? We don't, if we were working from here to here, we would have to kind of work with the bottom and then also work with the top. This makes it simple. Take care of the top, good to go, okay? So let's go ahead and do that. From here, we're just multiplying. That's what we're going to do on this next step. So multiplying or distributing. Okay, so we've got 2 tangent of theta times secant of theta times cosecant of theta. And then we've got minus 2 tangent squared, right? Tangent times tangent. And then cosecant. Okay? And then if you are cool with this, I'm just going to leave the bottom out of this. Okay? So I can save some time to writing. I hope we're all right with that. It's going to be a similar solution on the end of these notes, but just so I can save some time, right? Like, I don't have to rewrite this entire thing again because we're good on that, right? We're good on that. Okay, so stuff, and this stuff is here. Okay, so over stuff. All right, and eventually I'm just going to stop writing the stuff. All right. So, anyways, 2 tangent. Here we go. So we want secant theta minus tangent of theta squared, right? Think about what that is. That's a perfect square, right? So if we can get like secant theta minus 2 tangent secant theta, that's going to be part of our goal. So let's go ahead and look at it. Let's take out the 2. Okay. Let's take out the 2. I think that was the approach I took. No, just changing everything to reciprocal and quotients, and let's see what happens. Okay? Yep, that's a good way to do this one. So reciprocal and quotients is what we're going to do here. Now, the reason why I see to do that is because maybe there's some cancellations that will happen, okay? And we can kind of condense things down. So let's get everything to sine and cosine and see what happens. So 2 tangent, that's sine of theta over cosine of theta. Secant, that's 1 over cosine of theta. Cosecant, that's 1 over sine of theta. And then over here, it's 2 times sine of theta, cosine of theta. But then again, because it's, tangent squared, so sine of theta, oh, I'm running out of room. Cosine, bummer, reciprocal. Over here, last one, cosecant, that's 1 over sine of theta. All right, so from here, let's cancel everything that we can. All right, on this side, okay, I've got cancellation there, cancellation there. Okay, over here, I've got a cancellation here, cancellation here. Okay, so let's rewrite what we have. We now have 2 over cosine of theta. Are we cool if I write that as secant? Okay, 2 secant theta. That's it over here. Over here, I've got, let's see what I have, 2 times tangent. Let's see, this is tangent, and this is secant. So secant, 2 secant theta, right, the 1 over cosine, and then times tangent. Okay, that's what we're left with on that one. All right. Let's see the approach that we can take from here. This should be secant squared on the bottom. Glad I caught that. Cosine times cosine there, not just 1 cosine. Okay, cool. We should be good on that. And actually, I'm gonna rewrite the way I have this. I'm going to rewrite the way I have it as, see, we have cosine and cosine here. We want to make things consistent so we can actually combine these. So I'm going to write it as secant of theta and then times sine. Okay? So sine up here, but then we keep that 1 over cosine part. Okay? So let's see what we have from here. Okay, let's go ahead and pull out the secant squared of theta. I am running out of time on this one. Pause it again. All right, I changed my mind. We do not want to change this to sine of theta. Okay. Listen, I hope you're seeing the natural progression of all this, but it is important to do it this way, right? Because, again, that's how you are working on this naturally. Okay, so let's look and see what we have. All right, we've got 2 times secant of theta times tangent of theta. Now, if we're looking at this up here, this secant theta minus tangent of theta, I want something that looks like this, right? I want secant theta minus 2 tangent secant theta, and then tangent squared of theta, right? Because that's the FOILed version of this. So if I can get that, then we're good. Okay, so what we notice is we're close. We have this part. We have this part here. That's the same. And then we have one of these, or we want one here, but we have 2 here. So let's get rid of that secant and let's make it a tangent. And then that's where it ends up playing out. So we can use a Pythagorean identity here to get that last tangent. So let's go ahead and rewrite this. What we did here is we did some just rewriting. That's what this was. Rewrite. So we've got secant, okay, minus 2 secant theta, tangent theta, and I'm going to add a secant over here, And again, this is just rewriting. We split the secant theta. Okay, that's what we did here. All right, and then we're going to change that. We're going to use the Pythagorean identity. We're going to change it to, right, secant squared of theta, that's 1 plus tangent squared. There it is. Now we have the perfect square, right? So this is this part here. And then the plus tangent squared. All of this, okay, and then don't forget that plus 1. All of this can be rewritten as this. And then we also have that plus 1. So we now have that top part. This was just, this is just reordering. Reordering here. Perfect square factoring here. Okay, then we have it. All right. Again, hopefully you see that natural process. But what we did here, just to recap this one because it's a little bit much. We started off with the 2 tangent theta. We introduced the top and the bottom here. Now we have that denominator. Notice I didn't write it the rest of the time. Okay, because all we have to do is just show the top is the same as this, and we're good. So we rewrote some reciprocal and quotients. A lot of stuff ended up canceling after we distributed. Right. Then we're left with this. We can change this secant of theta to a 1 plus tangent of theta, tangent squared of theta, because that's helpful because we can actually get it into this perfect square. And then once we do that, it ends up working itself out. That is that video. Make sure you guys are working diligently with these. It's tough, right? You can see it now. I was struggling with this. Okay, it's a process. But I try to approach this in the way that you guys see it as well, which is blind, right? I don't want to try to use my notes because that's not how you see it, right? So you want to be able to do it. You want to see the process in its natural form, in my opinion. And it takes some struggle, right? You want to see a little bit of struggle in here. That's just what these problems are. Okay? You have a great day. Keep working with these. Reach out if you got questions. If you want, share your solutions, right? But really focus on the, like, I'll tell you now, like, the goal problems are 5 and 7. Those are solid ones that you should be able to do. 9 and 11, those are tougher, okay? But, we can try to work towards that. That's a goal, too. It's just a tougher goal, all right? You guys take care. Have a great day. See you later.